Okay. So, this is just a quick recap of the course content, what we said at the beginning and then what we have covered so far. So, you always keep it in mind with respect to what we said we will cover during the course, how much we have covered. So, let us go through quickly. The key issues are of course getting to know what kind of a jobs, just a recap, which is nature of the companies, 3 types of that is repeating, but it is important, and what is the kind of a jobs that are in each type of a segment, what they look for, manufacturing what they will look for, EPCM, so on like that went through. Then in all sorts of jobs, important to remember cost. The 2 questions repeatedly will come: how much will it cost to make a product, how much will it cost to make a plant to make the product. So, that we discussed some concepts on basic variable cost, fixed cost, return on capital investment and things like that. Finance also we dealt with in terms of balance sheet, how to quickly understand the balance sheet, comparison of this company versus similar company in the same line of business. So, it gives you why somebody is doing better, why somebody is not doing better, that sort of. Then Professor Nagarajan covered about these are too important. At the moment it may be a bit vague, but please spend a lot of time on this, because he made I think some 25-30 slides in each. So, it is a lot of information. You may not understand it, but that is very important to go through, because like I said in the past we used to start with that, but then we realized 40 slides going through like there was hell of. But in this case you have to relate to whatever we are talking about others to go back, which means why global companies are big in that kind of a area, why somebody is dominating, why somebody is not able to dominate, why Indian companies are the way they are like. So, this kind of a thing you will get lot of inputs by going through again and again. So, that is what we covered on that. Then I spoke about companies, manufacturing companies, we gave this quick example of what they will look for is cost reduction in existing operations. This trivial small example of heat exchange, that assignment we talked about, that we went through, just to give you a flavor. When you work for a manufacturing company, constantly you will be looking at, given a setup, how can I do better, assuming of course there is always a better way of doing things. It is always the case, because the designer or whoever it is, at one point of time he designs and installs. After that it is not as if the end of life has been reached. So, there is still some scope. You have to look, it will not be a breakthrough kind of thing. I mean, like I said, hype, going back to hype, the world's biggest, largest and all that, ignore, but that given plant can certainly make some improvements, make more money than what they are making. This is absolutely possible. So, that to give a flavor of that, we went through this assignment. So, that is what we did. Sometimes what people do, especially manufacturing companies, they always prefer to buy know-how from somewhere, and yesterday's failed example I am going to pick up. So, this keep it in mind. Most of the companies, for good reasons, very good, no blame, good reasons, they decide when they want to go for a new technology, simply go and buy it from a reliable source. What is reliable sources? Whether they have already built that plant somewhere, is it working, go and see that plant, visit it, and then ask what is the warranty and guarantee which you will give, how much will you guarantee me the production output, will you guarantee me the quality, if the guarantee is broken, what will you do to rectify, that kind of a thing is they get assurance. So, that is what manufacturing companies do. That is what we talked about, technology, licensing and things like that. Then and EPCM companies do that kind of a thing, and EPCM companies again are not technology creators, they are technology aggregators. None, lastly we went in and said, because everybody at this stage of your life and interest, you are interested in technology development. Give me a job in manufacturing, give me a job in EPC, give me a job in R&D and research. So, we switched. I also warned you, beware, it is a very exciting field, you can do a great satisfaction in this, but it is very high risk. And yesterday's example was how a failure was given as an example of technology development. So, technology licensing and all that went through. TRL is a concept which is approximately where it is, one level of technology, where is it to judge, we have a qualitative standard, that is TRL. So, we went through that. Then I explained about technology development comes from, this was serious business. Look at existing, it is working very well, something happens which gives an opportunity to do something better. That is the motivation for technology development. Example of caustic soda was given. Caustic soda was being made in particular way, mercury process, energy we spoke about. Though there was not an environmental issue, there was a parallel environmental issue. So, this got mercury got jacked. So, that was happened. Then how the membrane technology, what was that actually the technology breakthrough was 3 factors were given, right. Ion conductive, selective ion conductive membrane and problem of outside, energy prices. They joined together, technology became success. Patent, I think also I briefly spoke about patent. Then project presentation. As an example of a technology development, autothermal gasification, one portion, very large reformers, capital cost very high. Can you combine the primary reformer and secondary reformer? One is exothermic, one is endothermic together. ICI of all the companies, brilliant technology development company, started, but I would not call it failure, it did not take off for some reason. I also hinted at that time, it was a very good achievement, but it did not take off. So, then on desalination as an example, this was related to your request. When you say a project report, can you explain to me what is the kind of a thing that you are expecting. So, we took water, affordable water for lot of people, and then I went lot of time spending through that. Once again I want to request you, please spend time before it gets too late. You talked about assignment, no, take it as an assignment. It takes me 5 minutes to say that assignment I am giving you, you have to submit it by this date and I will grade you. I am not doing that, because I think we are not there only for grades. Grades are important, but I am sure that you are not there only for the grades for this course. So, assume that as if it is a assignment and do that. What I want you to do is, on water treatment, several existing technologies I spoke, etc., and gave one direction. Then I said 2 parallel attempts somebody had developed. One was this Vayu Jal business, making water from air. The other is solar based desalination, thermal desalination. I gave in that PPT, I have given links to these 2. Go through the link, work it out for yourself. When I say work it out for yourself, what I want you to do is that develop a flow diagram first. Whatever they are trying to do, you can read through, it is available, lots of information is available in that website. After that, try to put a simple flow diagram for yourself. Then you will know, by looking at the flow diagram, you will be able to guess what is likely to be the cost of making water, question 1. You will also be able to guess what is the likely cost of building a plant based on that kind of a know-how, because you will get some idea about the equipment, what is the nature of it. So, do that exercise, because it will absolutely fix the concepts in your mind. There is no correct answer of how I have got the rupees per meter cube worked out very well and rupees per million liters of water. That is not important. The approach what you do is very useful, it will be very helpful. In fact, it will help you a lot in this project work. Okay. So, that is what we did on desalination. Green hydrogen I dropped, because suddenly I discovered one team said we want to work on that. So, I just dropped, instead I brought with this failed technology. So, with that, what else is there? Most probably my lecture part will come to a close at this point of time. Then Professor Nagarajan, he is still recovering, hopefully next week he should be all right. So, he will come out and take over all this. I will come back and join you at a later time, which is at this point around 10th of April, where I will take time on all that you have gone through, you have an understanding. Now, what happens when you face a typical interview for a job? How to prepare for that, right from, it is not as if a fellow is calling you for an interview and therefore, you have to prepare. That was my days. Actually, it need not be my days also, but we were scary cats. We were always worried whether I will get a job or not. So, that was my nature. It is not at all true. You will get what you want to do. It may take a little bit more or less, but absolutely there is no problem, because the economy is changed, people are becoming much more well informed than my generation is. So, there is no problem whatsoever in you will get what you really want. So, instead of looking at the interview as attending to meet somebody else's requirement, I am going to say take the opportunity of preparing yourself to say what do you really think you should be looking at the opportunity, so that your goals are satisfied. So, that is what I am going to do after 10th when I come back, then of course, we will do the project presentation. So, with this, now let me get back to our sad story. today I am going to post this in the Moodle slide. So, it is not important for you to look at the slides, but I am just keeping it for. If you recall yesterday's class, what I said, this company, the background was very clearly polysilicon was to be developed, and a group of people set out to develop a technology for polysilicon. They made lot of efforts and the quality was good, product was coming out of the capacity in which we desired. Whatever capacity we wanted, we got that capacity. Whatever quality we wanted to make, that we got that quality, internationally certified, but it was not meeting the competitive market demands. So, whole thing was closed down. So, I said half seriously and half jokingly, it was a failed technology effort, but I want to be a little bit more serious in this class and look at it as a case study. I am detaching myself from that. I was a very keen player in this. So, I am now going to detach that part and then critically analyze as a case study for the class what went right, what did not go right. And so, first of all, question is, why was it called a failed technology? Remember, in the case of ICA's development of autothermal gasification, I did not call it as a failed technology. I said it did not get wide market share, because they actually proved the concept for the scale of operations that they wanted to have. You remember, they were looking at, if you recall, very large ammonia plants. Biggest cost item is this pyrethrum reformer. You have seen the flow diagram, horrendous flow diagram. So, they said that by that and secondary, if I combine, at least for a smaller sized plants, at least for a smaller sized plant is very important. They did not start, I am saying this is about 1980s. That time the typical ammonia plant were of the order of 1500 tons per day. There were plants of 900 tons per day, and I gave my own plant, which is, I said, 40 tons per day, right. So, there were sorts of ammonia plants available. So, they said we will go for something called a mixed segment, 500, 600 tons per day ammonia plant. For that kind of a market, we will come out with a design which is cheaper in terms of investment cost compared to alternative way of doing things. So, that was their value proposition. When you looked at it from that point of view, actually for a 500 tons per day ammonia plant, if you made it by the conventional method, or if you made it by the ICA's autothermal reforming method, you will find that the capital cost was some 25% lower and the energy penalty was not there. Actually, it was almost the same energy as the other plant. So, actually anybody who is willing to put a 500 tons per day plant would choose only this, because he is getting a lower capital cost, he is also getting at the same operating cost. Why will he not? Therefore, it was not, I did not use the word, it is a technical failure, it is a thing which did not take off. This is important to understand, and I will relate it to this polysilicon example, the differences. Why it did not take off? Because by the time 80s, this was they took about 8-9 years developing this, right from lab to pilot plant to big plant, and their own ICSI in UK, one of the locations, they converted that existing plant of that capacity as a demo piece, because finally anybody who wants to buy the technology will say, where is it working there, can you show me, right. So, you have to have a demonstration plant. So, they built up, but this happened between 1980s to 1990s, 91. Major changes took place outside the world in global economic conditions by 90s, which is lot of globalization, people interacting with each other. Every country said import, export should be more open, this making it in their own country kind of a thing. Every country had this, my country, like USA is now saying MAGA, make America great again, like that kind of a thing. That period was actually the reverse. Everybody talked about globalization, everybody talked about, right from Iran, everybody talked about globalization. So, what happened was, with that in mind, setting up mega sized plants, 5000 tons per day of ammonia in countries where natural gas is available just like that was an option for most of the end users, because all these technologies with respect to end user, this is a very important point. Whenever we talk about technology, you should always say finally who is going to buy the whole thing. Why anybody will want to buy ammonia technology? Because he wants to make ammonia, right. Why will he want to buy ammonia? Because he wants to make use of ammonia. users of ammonia felt that if you can tie up with countries like Qatar, where natural gas, I believe you may not get drinking water when you bore, but you get natural gas. So, that kind of a lot of gas availability is there. Every company started having a joint venture with Qataris to form major ammonia plants, and ammonia technology was not limited only to ICI. Ammonia technology is Haldor-Topsoe with Kellogg and Root Brown, and so many people are working on that. These guys took a different view. This is where intelligence, market intelligence, technology development means not only technically strong, but those companies took a view future will be big size plants, because economies of scale works between a smaller plant and a bigger plant. Chemical plants especially, bigger plants have an advantage, fixed cost per ton comes down. They develop massive big plant designs. It is same, basic technology is same primary reformer, same secondary reformer, everything there, excepting the sizes become bigger and bigger, and it is not a easy thing, same technology to build a bigger plant, because right from the heat flux calculations of the furnace to the equipment required, there is a big thing. It is not as if there is no technology development between a small plant and a big plant. It is a different kind of a technology. The chemical engineering may not be different, but applying the chemical engineering is hugely different. They successfully developed. So, during the 90s, if you go through the history, the end users started preferring going in for massive big plants, and finally found that the cost was much lower also for them. So, in that market conditions, ICIs, there were no takers. Stop that story here, come back to cry story of polysilicon. Polysilicon, what happened? Now we have to go back and take similar stories. Why are we doing this? That is the first question, right? We should think any technology you are developing there for whatever purpose, like that is one of the reason I am asking, when you choose your project, I said name the project, but also come out with a purpose, and you will find, I hope surely you will find your initial statement of purpose. As you keep talking, that is why I want to start it as early as possible. You will find, I am 100% sure, after 1 or 2 rounds of discussion among yourself and hopefully with interaction with me, you will change your statement of objectives, because what appears to be a good thing to going on some critical thought might change. So, come back to polysilicon. Why are we building this polysilicon? So, we have to know some user of polysilicon is there. Always the starting point is technology being developed because the product is required by somebody else. Who required the product? This company which wanted to get involved in this, what is that company? First I have to tell you, they were a chemical manufacturing company. What chemical they were making is, they were a medium sized PVC company, polyvinyl chloride. So, they will make PVC granules and then sell it to people who buy those granules. What do people do after they buy the granules is depends. Common use was pipes, water pipes. If you see in that, it is low cost, long life, not hazardous like lead pipe or whatever it is. So, water pipes is a good choice for PVC pipes. So, these guys buy the granules, you have an extruding machine, make whatever fittings, elbows, tees, joints, pipes, valves, everything you can make out of. This is one market for that. Second market is footwear. If you see our bottom of the most of the shoes or chappals will be PVC. So, that is one. Then carpet makers, they want the backup. On top you will weave something, but at the bottom you need some flat piece. So, that is one. And the fourth market which was emerging at that point of time was windows. In the olden days only wood. You go to any house, window means there will be a frame, wooden, nice polished, and if you are a very rich guy from Kottayam, all teak wood. So, some people will put aluminum or some country wood or whatever, depending on your thing. Aluminum does not look nice, right. Even now if you go through all our offices, look. So, PVC was thought of a thing there, because it was in order to make PVC, PVC is not very friendly towards sunlight. So, if you expose it to sunlight for too long, it will crack and peel off. So, the windows all the time are taking it. So, PVC was converted to UPVC, which means it is further kind of modified to take to protect against ultraviolet protection. So, it is called UPVC. There is a company which started fashionable design of those windows and they look beautiful. I mean most of the, if you say 5-star hotels, if you go through that, it comes in various shades. So, it will be like absolutely contrast will not be there, noise proof. So, you can close the window, noise gets shut off, thermally resistant, therefore AC. So, a lot of benefits. So, 4 end users were there. Story going back to PVC company concentrating on that market, making PVC granules. Why are they suddenly thinking about this great thing called polysilicon? I gave a lot of story yesterday, some of it will come here, that India wants to be contributing to global warming and blah blah blah, and therefore renewable energy and therefore photovoltaic cells and all that. This company had no clue whatsoever about what is that they are talking about, but they did something to say that is there a market? There seems to be a big market, then why as a PVC company you should get involved? I mean everybody finds a market, they can do whatever they want to do. So, now the process of making, yesterday proved, is there is hydrochlorination. You take impure silicon, hydrochlorinated, you get this trichlorosilane liquid. This company in the process of making PVC had extra HCl comes out, because in the PVC polymerization you will find HCl is a waste product that comes out. Normally you have to scrub it, absorb it and sell it at a low cost to whoever wants to take it. It is actually a nuisance problem. You would even be willing to pay a little bit of a money to get rid of this, because your PVC business is so good, you only want this outlet to go. So, somebody had a bright idea in that management to say we have got HCl, now looks like this process requires HCl and there is a big market for it. So, we should be able to make it at a cheaper rate. Okay. Now, go back to flow diagram and yeah, this is something which at the end of the project we got, but before the project was started this kind of a clarity was not there. But actually as it turned out, these are actual data. If you see HCl gas that is used, this is all items required for making 1 kg of polysilicon. That is the final, because polysilicon plant output is polysilicon, whatever raw material goes there per unit. Take HCl gas, 7 kilos of HCl is used per kilogram of, this is actual experience from the plant. I have not taken you to the stoichiometrically and so on, like these are actual figures you take, but take 7. The HCl price actually it is, they were paying some money more or less to get rid of that. So, it is a low cost item, though it was a great motivation, I have got low cost, I can make use of it, its contribution to the product cost, look at it, is less. So, on this basis it is quite unlikely somebody will have a major competitive advantage compared to the other guys. So, this is the lesson number 1. When you want to develop a technology, why are we developing the technology, should be lot of time should be spent. Do not be taken in by the first thing that comes. In this case actually what happened was, there is a big booming market, of course which is not a big booming market in the world, tell me. Everything is big booming market. Then second question is, why will I be able to do it better than compared to others? Answer is, I have got low cost HCl, and the contribution of that, if this chart was available to the decision makers in the beginning, they would think 3 times. If 14 rupees became by magic 2 rupees, 12 rupees per kilogram, ye kya yaar, what is this big deal, that on this basis are we going to compete or not? More importantly, automatically your eyes will go down to where is a big value. So, it will catch power and somebody will say, why this power is becoming very high? If you are able to come out with a technology where the power consumption is brought down, then maybe we should look at it, right. This is a, on hindsight it is clear, but I feel it should not be hindsight, it should be foresight. Before you develop a technology, reason why you are getting into the technology should be very clear. So, that is lesson number 1 from the management principle. Second point of
for the foresight part, the power was not, the power data was not available with you. How
yes,
did you?
good question, which is why we should spend more time on existing process. I told you, existing process we should compare. Now, if the difficulty is, if you go to existing manufacturer and ask him why he will share, because they were not, you are a competitor, you are coming me and asking me a question. In methanol they will share, because what competition you can do? First of all, if you have 3,500 crores only, you can set up a plant, and methanol is methanol, array take it, if you can make it, you make it. So, commodities it gets sorted out. In fact, in all this chemical association of big time commodities, what I mean by commodities is common stuff, acetic acid, methanol, free exchange of information goes, because they are so confident. Take care, what will you do with that? You are a bigger guy, means do it, na. Finally, it will come down to different thing. This was high tech area. So, therefore, they were, what we should have done is, we should have picked up, done a, engage somebody or go through internet or look at the patent literature, survey it and get some feel of this, because the Siemens process is known. I said 1950 patent. So, we have to spend some time, not from studying from the technical point of view only, technical point of view, convert it to a flow diagram and converting it into some guess about what is the cost to make the product and what is the cost required to invest in the plant. This exercise is key, and this exercise was not done. Now, you may turn and say, why are you saying exercise was done? You are supposed to do, I mean what the hell, you are recruited for this job? Good question, right? Quite so, but I gave you some of you yesterday who are present, you know what happened. So, that is lesson number 1. You should really do this exercise approximately, but then zero in on why is that you are going to develop technology. First lesson. Second lesson is, go back and then say, power, you found out power is very high, but we still went ahead and used this Siemens process. Now, I will give some learnings for technology. Imagine the first guy who developed, because there are a lot of guys who developed it also went through the same route, right. Why did they develop the technology? Because basic point is, of the 3 stages, from impure silicon, what is called metallurgical lead silicon, chlorinating it to make trichlorosilane. Let us take the first step and look at it little bit. This we did.
Sir, another question. After you realize that the power, I mean the cost is for 1 kg is very high, and you realize it's because of the power, and you were halfway there, right?
Yeah.
Figure out that you can just replace with bed reactor. Why did you not move?
Excellent question. So, if I said also this whole effort from the time, I think we will go and build some plant to actually getting to a stage where we got the product quality capacity, right, but this number was about 2 years. Actually, in my opinion, it is a phenomenally good effort, because actually what we were doing is a pilot plant. Because what is a pilot plant? You have beta from lab, in this case research literature here there, and that lab you have to go to an intermediate, look at the TRL lessons from an idea. Why there is 7-8 stages of TRL? You could have had idea, final plant. Intuitively we know there is a hell of a lot of work that we have to do in between. So, if you look at it that way, if this was seen as a exercise of developmental, then first of all the goals will be, in 2 years you are not expected to make a final plant which is fit and ready and competitive for the world. This requires management thinking. When I say it is not a technologist or a research scientist job, he will play a very important role in this. The guys who are interested to develop the technology, go back to the goals, is that what is the goal of this company, I will tell you, and what was the goal that is required for technology development. First start with positives. Technology development companies, they do this kind of a thinking, spend time, prepare. Then they set up some idea, various TRL, sit back and analyze performance metrics. So, this performance metrics will be very clear. Oh, power seems to be the performance metric for this, is it? So, why is it very high? Question will come. Then we will go back and say this. yesterday I went quickly, but I think it is important to understand. Yeah, this is a typical rod. So, this rod as it is, once the temperature has to go up to 1100 degree centigrade, on the surface this trichlorosilane reacts and silicon builds up and so on like that. It is radiating heat T power 4 minus T power 4 to any T which is lower than 1100 degrees. That is the purpose of radiation. This is inside a reactor. So, the reactor walls are a good case. Reactor walls are colder than, this is hot because you are electrically heating it. This is cold because it is not heated. So, there is some amount of radiation loss takes place. Can you avoid this? If you got 1100 degree centigrade, it will radiate. You cannot avoid it.
Why do you not, put the electrical jacketing on the outer wall?
If you put electrical jacket, if you also make it 1100, silicon also will grow there.
So, if we use radiation shields, then
Such as?
material as of now for that temperature range.
No, maybe not make it 1100 temperature, maybe somewhat less which we can curb.
If it is lower, then accordingly the heat loss will be less to begin with. But this kinetics of the reaction, activation energy requires starting from SiHCl3, that is, for that reactant 1100 degrees kicks off. Higher the temperature, faster it is. Of course, at 1400 the silicon itself melts. So, you have a window. We have tried because we had a plant, no, we built that plant. 800, this rod is nicely getting heated up and staying there, radiating energy at 800 degrees, no chemical reaction. So, that is another thing on. Interestingly, if you go back and say 1100 degrees, it is below that, it is not reacting, is it? That is because you are starting with the trichlorosilane. Is there no other silicon compound which will react? If that question was raised by one of the people, actually yes, we raised it. We found there is another chemical called silane, SiH4, like methane, silica base, silane. This breaks down at 650 degrees Celsius.
So somehow converts
Or do not even, you started trichlorosilane because the patent literature said trichlorosilane breaks down at 1100 degrees centigrade, we have hydrochloric acid we make. Start with making silane, you have to research, find out how it is being made, make silane, but then HCl. So, the idea was, you should be clear, are you developing technology to be competitive in the global market, or you are developing technology because you have got some peculiar ideas of what is life like. That is the funda. So, let me not go back to again and again. So, there are lots of funda things, come back, but we are going back. So, here to minimize this, what could have happened and what people have done in the next generation, so on like that, they just said if this heat, because this temperature has to be low, it goes there, what happens, I put one more rod next to it. So, one rod, the other rod, at least path of this rod will be blocked by this. So, when this also becomes 1100, this 1100 and this 1100, that surface area, net there is no loss of energy. Of course, this portion is losing, this portion is losing. Then the question is, put one more rod there, right. So, eventually our, you can imagine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, this is what some clever guy had gone ahead. But in the Siemens, it started with 3 phase current. So, there were 3 loops. This is during the time of Microsoft, cut, paste, our group. So, we took 3, we got, if you had started with 1, I think later on we found in IASC researchers they had only 1 loop, they did not report what is the energy consumption per kg, they must have had some huge figure. This design with no other change will give lower energy consumption, you got the point, because only this portion is losing it. Now, getting back to the next jump, you asked a question, after you have got, if you had spent time on this, okay, today we are only 800 kg, it is not economical, but we will still spend effort based on that learning to take the next step forward. That thinking requires, again your goal should be, I am actually developing technology to be world beating or at least competitive to the world. This company's thinking was not like that. What they had actually turned out is, what they were doing with the silicon, first of all, that I have to tell you, they were actually wanting to do something with the silicon, right. From PVC guys selling to footwear manufacturers and pipe manufacturers, they thought the silicon, two end customers came. One is BHEL, Bharat Heavy Electricals, Government of India company, other is Bharat Electronics. These guys were under encouragement by our Government of India, you should also do something about solar and all that, and BHEL basically is a power company, make boilers, electrical equipment. They were under pressure, do something on renewable. What is this, always talking about coal based power plant. So, they wanted to get into renewables. So, they said they invested equipment where if you supply them wafers, they will diffuse, assemble and make some solar cells. Key point is, they are not trying to build a business for solar to be globally competitive. They were under trying to meet their social obligations to the government by, hey, kuch bhi karna hai na, something you have to do like that. That is our customer, to add to our confusion. So, when that customer came, we thought if we make it like that and then give it off to him, first 2 years as we built it, it was working. This product, after the quality was certified, they bought whatever price we set, you have to only cover it in the selling price, no. So, now how they agreed to buy at a higher price is because that was also the time where globally there is a huge shortage of polysilicon, for reasons I told you. Everybody is talking about solar, suddenly the consumption went up, capacity is not going up. So, the prices of polysilicon at the time, imagine this price what I said, go back to the Excel sheet. Yeah, 1369 rupees, right. The selling price at that time, what was it? 28,000 rupees a kilo, $400. I mean, okay, at that time dollar was not 70, let us say 50 rupees. So, 400 into 50 is 20,000 rupees. So, if you can sell it at 20,000 rupees, this itself is not a big deal for you, right. So, this was the first few months. Then in global thing, everything comes to an equilibrium after some time, some flavor. So, the market prices from learning for us is, today the price is 400, like if you want to do a project, you want to know what is the selling price of the product, how will you know? You will go and do some Google search, it will give you what is the price. Do not be taken in by that, especially for chemicals, do not be taken by. You have to go through the last 10 years trend, because this demand supply is a big thing, practically speaking. We discovered that few years back polysilicon was getting sold at $35 to $40 a kilo, sharply went up to 400. Everybody thought, did not ask why is it 400, if it goes up it can also come down, it is like our whose share market it is. Suddenly it is going up, everybody is becoming a billionaire, right. We do not ask why the share yesterday was the same world, why today there is a 40% increase in the share. Similar thing happened to that commodity. So, when that prices collapsed, our two customers anyway they were just doing, not they didn't want to build world class business, want to do something. China say it comes here at $40, yeah, why should I go to this company and buy it at that drop. Third point is again what happened is, because of the lack of vision, the question that you asked is, from here what next, and others if they are doing, why are we not able to do, accordingly we will modify our thinking and make it like that. Did not happen, essentially because this is not a technology development company. One line answer, they are a product manufacturing company. When the going is good, they are interested in the product. The happy news is, from that time 2005, 2023, only small things have changed. Even today there is no one to make polysilicon, but intelligent companies which are no big companies who have taken a position that I will be globally playing a role, they have gone ahead and acquired companies outside the country, because these guys thought, array again coming back to IIT Madras, find this MS Srinivasan and try to develop all this. Go back, find wherever people are doing like that, there are a lot of researchers, buy a few companies, pay them money, money was not a problem, but it is available right in time. If you come here another 2 years, at the end of 2 years whether we will be staying on to this project itself is doubtful. I might have got some better idea and say I want to do this research and I will go away. Those companies, like I made one point, no, technology development companies stay focused on this for long period of time. They spotted the companies, bought over that companies, now they have got their entire value chain mixed up. So, the lesson for technology development is goal. You have to be very clear why you want to do that. You have to be globally competitive, then do. Government is also now playing its role, because at that time the government said I will reduce the customs duty, I will make it easier for you. So, now they are saying that these are all short term. So, they say you come out with a program and tell me over a period of 10 years, 5 years, how will you make it competitive. If you give me the program and if I am convinced, during that period I will support you. So, this money whatever we need to spend in a pilot plant, etc., that is not an issue. In fact, in my opinion, in one of the lectures I mentioned about who was this guy, Narayana Murthy in IISc, talking about why not a single global technology has been developed out of India, like that he spoke, right, something I said. If you ask, it is not for want of money. And then CNR Rao, who is one of those Bharat Ratna types, big time research fellow, he came and said that is because industry fellows like you waste money, they do not support R&D, we should give lot of money for R&D in academic institutions, IISc should get triple the funding, whatever. Maybe there is some point in, but the real point I think was, in order to do that you must have a vision, and this vision is not, you do not expect it from the research person. After all, he is doing a good job, he is coming with his thinking and so on to that, right. This is very good. How many countries can boast of such knowledgeable people? But you do not just leave everything to somebody else. Internally, companies, few individuals must have exceptional understanding of technology. Go back to my lectures. Exceptional understanding, or at least a guess of what is going to happen in the future, and stay on that job for 10 to 15 years. Then possibles are there. So, that is the lessons of this failed technology effort. Fluidized bed reactor, last 1 minute, is how did it help us? We actually thought of that, because once we knew that this is where we are losing energy, fluidized bed, the point is if you want to test it out, come to practical terms. Saying fluidized bed is clear, but you have to, how to do is, first of all, this is temperature is fairly high and the particles are growing. So, fluidization velocity, some of you will remember there is a minimum fluidization velocity, which is particle size density you will calculate, but dP, one particle size. Here first of all there is a distribution of particle size. Secondly, growth, and therefore they change. So, it is a dynamic fluidization bed you must have. So, the conditions of fluidization should be also changing with as the reaction progresses. Secondly, you must, fluidized beds hit the walls of the reactor. I can't think of a fluidized bed which does not touch the walls of the reactor, just fluidizing. So, when it touches the walls of the reactor, it will pick up some impurities, because the reactor is made out of some material of construction, right. So, it might pick up impurity. As it turned out, the silicon grade polysilicon for PV grade, these minor impurities are acceptable, but for semiconductor grade, even today Siemens reactor is the way to make it. So, it is not gone out, but more number of reactors have been packed, and accordingly these guys semiconductor guys pay a much higher price, not this. It is now become polysilicon for PV becomes a commodity, $30–40. Still the price of $250–300 is there for that ultra pure, this fab you all hear about, Taiwan semiconductor company all making ultra clean, they even everybody is going like a space suit and all that inside the plant. That kind of a purity still Siemens is away, fluidized bed won't, because it will pick up. So, there were lot of technical issues, give another 3–4 years time, work on it, surely somebody will crack. But today's reality is people have found, why do you have to redo the whole exercise, world is a place, if there is some clever guy who is doing it by his company, he is happy. You fund him, he is very happy to fund, whether it comes from, unless some fellow says India say all this, like China, there is a big thing going on, anything China, they are clever guys. I mean, I have terrific respect for Chinese. Tomorrow if one fellow starts against India, oh Indian guys will come, like they already started, you know, in Silicon Valley and all that, oh Indian guys they will come and take over their jobs, everything they will swamp us and all that. Maybe there will be a swing back of the clock to going back to. So, that is what it is for the class. So, with this I will close and probably meet you again on 10th April. In between I am available, 3 groups have given their projects, other 2 please finish it as early as possible, and then check, send the email to me your times etc. We will work with you and then try to say how you can capture all the ideas and try to make a project which makes sense for you.